Hello everyone, my name is Taylor McCampbell and I'm part of the Red Teaming AI project here at Cedar. And today I'm going to be talking to you about breaking CUDA and Nvidia Jetson Nanos. So first I'll introduce the team members. Myself, my name is Taylor, as I already said, and I'm a senior at the University of Wyoming and a computer science major. And I'm also an INL intern. And then on the project with me is Will Brant. He's also a senior at the University of Wyoming and also an INL intern. So moving into a little bit of background about the project, we're seeing artificial intelligence deployed on more and more critical infrastructure or critical ecosystems. So that could be anything from self-driving cars to water treatment facilities. Anything that affects public health and safety is what we would consider a critical ecosystem. So artificial intelligence and specifically machine learning algorithms and machine learning models are getting deployed onto these systems just more and more. And so when we have software running on systems that impact public health and safety, any attack vectors that could compromise or lead to exploitation or anything that could affect the physical processes of the infrastructure is obviously going to have catastrophic implications. Loss of life or severe injury or et cetera, et cetera, et cetera. So yeah, that's the background of the problem in terms of the infrastructure side, and then getting more technical, we could talk about Nvidia GPUs and CUDA. So CUDA is well, it stands for Compute Unified Device Architecture, and what it is it's just a parallel computing platform that was written and developed by Nvidia for their GPUs. And so we're seeing Nvidia GPUs and CUDA being used in public and the private sector on these types of infrastructure. So that's why we are looking specifically at these technologies. And during CUDA's lifespan, there's been one reported CVE that involved the buffer overflow error, and that was on the CUDA toolkit, which is a piece of software that sits over CUDA and makes it a little more user-friendly. So getting into the problem that we want to solve is, can we utilize common attack techniques to obtain privilege escalation or arbitrary code execution with CUDA on an Nvidia Jetson Nano? And so if we can do this, that's a proof of concept that any board running CUDA, any NVIDIA GPU running CUDA is vulnerable. The methods we want to use to do this are the common attack techniques, like I mentioned before. The main one we focused on so far is fuzzing. And so that's when you have a function and you feed it lots of bad input, or especially crafted input, to try and make it have a segmentation fault or throw an error or anything you can do to mess with it. And so we also want to move a step further and attack open source libraries like Hugging Face and like TensorFlow, looking for really any vulnerable point in the machine learning pipeline with those two open source pipelines. So our current results are centered around fuzzers, which I mentioned before, but they're severely limited. So fuzzers are in their infancy, especially the open source libraries that you can build your fuzzers off of without building it from the ground up. So TensorFuzz is very young, and there's also a fuzzer that Google put out that's very young, and so that they don't have very good documentation. They haven't been explored very well. So that's one limitation of our results, is that the technology is kind of hard to understand, and it takes a while to understand and really get to a point with your knowledge on the subject where you know what you're doing. And so that's been a challenge. And then also, it's hard to get solid results looking at attacks, because you have to be very clever and you have to craft very specific attacks, and you just have to keep working at it until you're able to get what you want. So because of that, it's pretty hard to get solid results on these models, because you have to have really, really cleverly and well-crafted attacks. So we've made some basic fuzzers, but they're very limited. So like I mentioned before, a challenge that we have is fuzzing is challenging in itself. It's a challenging thing to do, so you have to spend lots of time narrowing down and looking at very technical things to be able to do your fuzzing. So like how a function works under the hood and what input it could possibly accept that would pass off as valid input, but isn't actually valid input. And so that's been a very hard challenge, is getting over that hump of how do we continue to craft clever attacks and narrow down our focus without going in the complete wrong direction. In the future, we'd like to create reports on reproducible attacks that lead to privilege escalation and arbitrary code execution with any machine learning pipeline. So the scope of the project is very broad. And in this case, we're specifically focusing on CUDA and Nvidia GPUs. But in the future, the scope of the grant is basically just any part of the machine learning pipeline. So that's what we decided to focus on specifically at the moment for proof of concept. But in the future, we'd like to move forward with that and start attacking all the different parts of the pipeline. So that is the project in a nutshell and the presentation. So thank you for listening, and take care.